Hi, this is Kevin. So we just weighed our glass. So now we're gonna actually get into solving from the weight how much of it we actually have in moles and molecules. So here we are. I'm just gonna unhighlight everything, and that's what you're gonna be writing down. And also, this is going to be more in-depth than the next video. I just want to make sure that we're all on the same page here. So this is going to be a little bit slower. So it might be a review for some of you. But let's start here. We have the initial weight of 90 grams that you saw on the scale, right? And so we're going to set it equal to 1 mole of glass over 60.1 grams of glass. And I'm just going to call silicon dioxide glass so it's easier for me and easier for you. So if I say glass, I'm referring to silicon dioxide. And so you might be wondering why this number is here. And so I'm going to refer you to, I bet all of you remember doing unit conversions in Mr. Nelson's class. If you do not, I will just quickly go over it. You cannot see up here, but this is 13.4 inches. Let's say we're converting inches into feet, right? And we're starting off with 13.4 inches. The first step we need to do is we make the table, right? And then we say of these 13.4 inches, 12 of them fit into a foot. This is exactly what we're saying over here too, right? We're saying that 90 grams of silicon dioxide is fit into this number, which is equal to 1 mole. And so I'm going to prove this real quick in case you guys are still confused. The reason why this is because you have the mole ratios, and actually they're right on the periodic table themselves. So if you guys don't know why 28.1 grams of silicon is equal to 1 mole, let me just pull over the periodic table real quick. The atomic weight of an element is equal to its mole ratio, or in other words, if you have 12.011 grams of carbon, that means you have 1 mole of carbon. Similarly, if you have silicon here, 28.085 grams of it is equal to 1 mole of it. So let's just go for a crazy one here. If we have platinum, we need 195 grams of it to have 1 mole. So knowing that, let's go back here. That is why 28.1 grams of silicon is equal to 1 mole and 16 grams of oxygen is equal to 1 mole. It's because of their atomic weight. And so knowing this, we know that silicon dioxide, it's not just silicon and oxygen, and it's not just silicon. Silicon dioxide or glass is one silicon and two oxygens. So basically what we're doing to get the mole, to know how many grams are in 1 mole of glass, is we're setting this equation up of 1 mole of glass is equal to 1 mole of silicon plus 1 mole of oxygen plus 1 mole of oxygen. So we could condense this actually and say 2 moles of oxygen and just erase this last part. But I'm just going to keep it separate for now. And so what we're going to do now is we're going to substitute in the amount of moles that oxygen is and that silicon is, right? So we take their atomic weight from the periodic table and we're converting it to grams. So 1 mole of silicon dioxide is equal to that much grams of silicon, that many grams of oxygen, and all that added up is how we got the 60.1 grams of silicon dioxide. So as you can see, all of this whole thing, the 60.1 grams is equal to 1 mole. So that is why, or how we can convert to moles. So let's just go back down here to where we started. Like the reason we got, I'm just gonna reveal the answer. We already are at our moles, so it isn't even that hard to convert. And the reason we're here is the same as you would do up here. You cancel out like units, so you cancel out inches and you're left with feet. So we can cancel out grams of silicon dioxide, right? And we're left with moles of it. So that means we're left with 1.5 moles of silicon dioxide. So that was pretty easy, right? Yeah, pretty easy. Well, yeah, let's now get into the molecules of silicon dioxide or of glass. So this will look intimidating at first, but I will explain to you how I actually got this number and why it's important. So here we have 1.5 moles, the number we got here. And what we're saying is when we have 1.5 moles, one of the mole, if we had only one moles, it would be equal to that many moles to the negative one. And so what that means, let me bring this up real quick. We're basically using Avogadro's number, and a mole technically is that big number of things. So if we have a mole of silicon dioxide, we have 6.02 times 10 to the 23 of them just floating around. So since we have a number of moles here, what we're doing is we're multiplying it by Avogadro's number, because that's technically saying we have the amount of glass and we're just multiplying it by the number of particles that is said to be in that 1 mole of silicon dioxide. If that doesn't make sense, I'll try to explain it here more. So what we're basically saying is when we have this 1 mole of silicon dioxide, 1.5 moles of glass, we're basically multiplying this by Avogadro's number because we know that 1 mole of silicon dioxide means that there's that many particles of it. So then we end up with this number down here. We have that many moles to the negative 1 or molecules of glass. And so now we're going to do this, but instead now we're just going to solve for either silicon or oxygen by itself. And so how we're going to do that is we're going to start off with 1.5 moles of glass. And so the reason we're doing this is that we aren't going to get a complete, we need to convert back to oxygen, right? But then we can't convert from 1.5 moles since that's an incomplete number. But we know back from the other slide, right? Here we have 1 mole of silicon dioxide. And if we go back to this slide, we can see that in 1 mole of silicon dioxide, there's 2 moles of oxygen. So, oh, whoops, wrong one. So since we know this, we can say that in 1 mole of silicon dioxide, there's 2 moles of oxygen, right? And we're going to say the same thing as we did when we were calculating the particles of glass by itself, that in 1 mole of oxygen, there's going to be that many particles of it, which means that we're going to have that many total molecules of oxygen. And also, when you're writing this down, just a real quick thing, I accidentally wrote O2. I meant to say just oxygen. So all these things that I'm crossing out here, those are just supposed to say O. That's my bad. So yeah, we have that many molecules of oxygen. So now we're going to do the same thing except for silicon. So when we have 1.5 moles of glass, that means that we can convert it back to silicon by saying that in 1 mole of glass, we have 1 mole of silicon. And so to prove that again, let's go back here. When we have 1 mole of silicon dioxide, we have 1 mole of silicon. Going back, knowing we have 1 mole, this is going to be easy now since 1 mole of silicon is equal to that many particles, right? And this is a universal number. This is a constant. So if you have 1 mole of any substance, for example, let me just cross this out. It doesn't even have to be silicon. We could have anything we wanted. We could have, I don't know, let's just write glucose here, C6H12O6. If we have glucose here, if we have 1 mole of glucose, we can multiply by this number because in 1 mole of glucose, there is that many molecules. But going back anyways, as I was saying, since we have that 1 mole of silicon, we know there's that many particles of it. and that means we get that many molecules of silicon. And to those of you who are still confused as to how there's more particles of oxygen and there's the same amount of particles or molecules of silicon that there are of glass total, this was kind of confusing me too. So I'll just say it for those of us who are confused, because it definitely did have me racking through my mind a little bit. So let's just label this diagram here. This is how many molecules we ended up with of silicon, oxygen, and glass, respectively. So let's just mark silicon with this orange color. So here we have 1, 2, 3. And then let's mark oxygen. Let's do it with this blue. So we have that. Those are all the oxygens. And then let's just make glass this color. So we're going to circle the molecules here. And so as you can see, we're ended up with the same amount of silicon as we do the actual glass molecules themselves. And so that was solving for molecules from moles and solving from grams to moles. If this is still confusing, the best way that I understood it is thinking of it as a unit conversion of going from inches to inches and then going back to feet. So if you still do have any more questions, you can basically use this video and copy paste everything I'm doing for the upcoming problems and you'll be absolutely fine.